Testing, testing. Okay. Oh, looks like we're getting a few people coming over. Okay, it looks like we're growing somewhat rapidly here. So this is fairly informal meeting, just to talk about the short period pulsators. So if anybody has anything they want to talk about, you're more than welcome to start. Okay. Questions, comments? Hello, Horace.
Hello, how are you?
Pretty good, kind of busy, but have some fun things to do. I get to sit on the 3.5 meter tonight down at in New Mexico. So.
Oh, cool. Hope the weather's good.
I hope so. We're on our training run right now. We just bought into the ARC consortium. So,
great.
I don't know what I'm going to do with it, but
oh, you'll think of something.
Eventually, yeah. So, well, we'll see what questions people have over here if they have anything for us. So you're working on anything fun?
Oh, a few things. Working on a number of projects, mostly having to do with long-term period changes of aurillary stars or Cepheids.
Okay.
One of the papers is with Wayne Osborne.
That name sounds familiar.
He's been around longer than me even.
Oh, okay.
But not as long as the data we're using. We're looking at the M13 aurillary star period changes.
Okay.
And we have data going back about 120 years there.
Well, that's a short line, so.
But that's fun.
Yeah, that sounds like a fun one. Okay, I see we're getting a larger group here. Hello, Joyce. Let's see, any other questions, comments over here? So those coming in later, welcome to the short period pulsator section. And this is fairly informal, so questions, comments, feel free to jump in. Not a talkative group, huh?
I was going to say the other thing that we've been looking at a little bit and is still fun are the aurillary stars with multiple periods.
Oh, yes.
And trying to pin down what periods show up, but also how the relative strength of the different periods changes over time. And so that's always fun, particularly since we have people out there who are giving us observations so that over a span of a decade or so, you can have 80,000 or more observations to play with, which is helps quite a bit with multiple periods.
Yep. Yeah. That sounds like fun too. Yeah, we got our robots going finally on our observation deck, so we can start things and let it sit all night, and not have to babysit it all night. So that's a big step forward. If I trusted our campus dome, it would be even better, but it's a little erratic. Then we could use the 24-inch. Hello, everybody coming in.
Hello. How are you?
Be good. Any questions, comments? Short period pulsators here. And we mean this is quite a range of short period from minutes to days, months. So we cover a lot of territory.
That's a good question. What's the upper limit regarding period to call a star a short period pulsator?
Probably the longest of the Cepheids. Anybody want to take a shot at that?
I've seen Cepheids go 3 months or more.
Yeah. So I guess that's our
pretty short.
Yep. Compared to our long period variable people, that's short.
Yeah.
Well, we have observers who range from those who like to see a whole cycle in a night to those who just like to get one observation a night.
Yep. Both are valuable. That's the thing.
Mm-hmm.
It's all valuable to us. Yeah, I like ones I can get 6 or 7 periods in a night if I can. So, welcome everybody. We're still growing a little bit here. So, any other comments from anybody?
One of the best things about short period pulsators is that you can see variability in real time. It's very good for beginners.
Yes.
Yes, I was able to see my first light curve with a friend of mine, and I introduced him to variable stars just by looking at the large high amplitude delta Scuti. And it was shocking to see the light curve there in real time, only after a couple of hours of observing. That was great.
Yeah, it's something I use for my own, like my introductory observing class for that same reason. It's not something that takes time. You can see it in that night. So, no, I totally understand that. Okay.
I was wondering if anyone has observed star spots or flares on Delta Scuti stars. I've read about those in the literature from people's Kepler observations, but maybe they show up in your amateur observations, but I'd like to know about that.
I haven't seen flares personally, but yeah, I haven't been looking at data quite as much myself recently. They made me associate chair of the department, and so they took all my time.
There have been a few observations in the literature that you may be referring to where there are oddball jumps in the light curve. And the question has always been whether those are real or whether it's some artifact in the observations. And the difficulty is that rarely do they seem to repeat. So it's hard to pin that down. I don't know, Jerry Samolik may have a better idea since he looks at billions of observations.
Well, most of the observations I look at are Larry stars. On Delta Scutis, I've seen a lot of light curves that change from cycle to cycle, but I don't know if I've seen anything that I would consider a flare. Of course, like Horace said, if you have an event that happens one time, a flare won't necessarily repeat itself. Sometimes it's hard to tell between a difference between an artifact and a flare.
Yeah, often the observations are being carried out when the unusual observation appears only in one filter. So you don't have the filter check either.
Yep.
I've been looking at test data for Delta Scuti stars And sometimes they're the right temperature and luminosity. I'm going to talk about this on Sunday, the Delta Scuti star, but they look a lot like those light curves of the binary that we saw recently, you know, in the last talk, with bumps that could be a contact system, it could be a spot. And I'm just wondering if anyone has seen things like that in your data too. Because I'm trying to figure out what these are. Are these really, they're not supposed to be binaries, because the guy who picked the sample that I looked at studied them all spectroscopically and didn't find any evidence that they were binaries. And he picked them because he thought they were single stars, but I don't know what they're doing. So maybe more observations will help if someone else gets a look at them, or even someone else looks at the data besides me.
No, I'm totally unfamiliar with that issue, so I have no idea, but it sounds interesting.
I do know of one case where there's a Delta Scuti that's part of a binary system, SC Linksys, but it's a rather long period. It's on the order of 3 to 30 years.
Yeah, there's a couple of the long period binaries, YCAM and dang it. Those are campaigns from a long time ago. I can't remember the second one.
I think I got observations on it too, and I can't recall it now either.
Yeah, the ones that Eloy Rodriguez was doing all those years ago. I can't remember them. I'm getting old. But yeah, I've looked at some of the tests. It's something we've actually were doing in class this week for my observing students, was pulling light curves out of the test database for some of the for some Delta Scutis and pulling them up on the screen. And some of those are intriguing because there's subtle differences curve to curve. And I wonder if that what some people might think of as flares, but they're pretty subtle changes. And they look like they might repeat actually in some cases. So, but there was more trying to watch over 12 students pulling data, so I wasn't paying that much attention to the light curves.
I was learning more from I went to the data mining workshop last week, and I learned about how to take the test data and read it into light curve and make plots, and then use V-star to make delta, look at the periods and the Delta Scuti periods. And some of those may have some contamination from nearby stars. We learned that the test pixels were really big, and there could just be another star with light, in the same pixel that is. And so I learned about some tools to try to, rule that out, or get rid of that, or at least determine whether it's happening. So that could also be a problem with my data.
Yeah, I actually saw that in a Cepheid. We were looking at X Cygni, which is a fairly bright Cepheid, and the data looks really weird for it in TESS for some of that same reason. I think because the pixels are so big, it's kind of like the Kelt data for searching for we do a lot of TESS follow-up on the planets, and it's challenging when there's another star those pixels are covering a lot of stars in some cases. So,
although even in the blended cases, even in very blended cases, the data can sometimes be useful for at least a period change study over a long period of time.
Yep.
Even if you can't disentangle the light curve, you may be able to still tell when the maxima and minima are.
That's true. Although
Yes,
we
have received several submissions to VSX with more than one type of variability for the same star, and they were incompatible. There were flares in an A-type star, things like that, and yeah, they turned out to be two different stars blended in the same images from TESS. So you have to be careful with that. Yes. I am looking at the list of eclipsing binaries with Delta Scuti components, and we have 114 cases in VSX. So it's very interesting. We have eclipsing binaries and pulsating variables. That's very interesting.
Yeah, those are bad. Probably the worst one is one of the Kelt targets that was a transiting planet around a pulsating star, and trying to pull that apart.
Small amplitudes for everything there. Yeah.
Yep.
In these cases, we have large amplitudes for the eclipses and small amplitudes for the delta scutis. But with an exoplanet, it might be very difficult to disentangle those variations.
Yep. Yeah, they sometimes refer to that one as the problem child because they can't figure it out.
Those systems are really valuable, though, because if you're going to try to do asteroseismology with the Delta Scuti stars, you need to have more constraints. And if you get a mass from asteroseismology and you have a mass from the binary or other constraints, it makes it a lot. You need more constraints. The more you can get, the better if you're going to do asteroseismology someday. So, but then I wonder how much the binary affects the pulsations, because there are some stars that are showing tidally excited oscillations, and
yeah,
I wonder how much of that. Well, I don't even know what to make of that period that I'm seeing. Is it intrinsic to the star, or is it something that's really being induced by the binary? So it makes it
yeah. I think some of the ones where you have the longer period eclipsers, so there's greater separation. I think you can get rid of some of the gravitationally driven modes. But I know Horace and I have messed around with AN Lin, which is a nightmare star in terms of a driven. Yeah, you remember that one, Horace.
Yes, I do.
But that one is a much faster binary. Well, at least we think it's a binary. It's not an eclipser, but we think it's a gravitationally driven mode, or it's a possibility because it looks close. So I got more data on that, by the way, Horace, that I just want to throw in the trash so I don't even look at it. But
oh well. Well, we haven't been getting much data lately with the students have been unable to get together in a group at the observatory to train them very well. So things are going a little more slowly.
We have a comment in our chat about asking about interesting stars in the southern hemisphere. Yeah. And I bet there are lots of them.
I was going to put a list in. I've been actually trying to get a list together to put, give some options for down there. Some good follow-ups, or maybe some new variables that haven't really been picked up on before. I've been going through some of the different archives that are looking for other objects and stumble on variables, and I was going to give some of those to. There's a number of southern hemisphere ones that I can't get to. It'd be nice to have somebody down there following up on some of these. So I'm hoping to get a list of southern hemisphere ones put together in my copious amounts of spare time.
My talk is going to be on test stars from the northern hemisphere, but in cycle 3, like right now, I put in a whole bunch of southern hemisphere objects, and I have no idea what I'm going to find, but I bet some of those will be really useful to have some follow-up observations on. So I'd like, and my collaborator would like to get spectra on them, but he's in the northern hemisphere, so he's going to have to find somebody in the south to do it. So yeah, I'll try to remember to, maybe I can send those to this short period variable section when I look at them, and we can decide if there's some follow-up we could do.
I think there's people that have been asking about what they could do maybe spectroscopically if it's some lower resolution things. I think there's some people that have the equipment that would love to contribute. So if we get a list on the page, that might really help. And
I'm looking at stars that are eighth magnitude or so, so they'll be really bright, and that would be good for southern hemisphere observers to follow up on. So the other question I had about observing short period variables are gamma Dor variables, and how much work has been done by amateurs at looking at those, and those are harder to do because the period is longer and you have to look at them for a long time with the same setup and to get anything consistent. But what is your experience on that?
I haven't worked on a gamma door in a while. I've been kind of leaning more, I've always been more Delta Scuti, but it's something we should look at least putting a few on the page for people to maybe experience that, because you kind of get more of the periods of the RLRs, but the amplitude's quite a bit down. So they are a bit more challenging. It might also be fun to get a couple of the hybrids that are the mix of Delta Scuti and Gamma Dor as well, because that could be exciting for some amateur observers to see.
I see that there are 2 eclipsing binaries with hybrids, Gamma Dorados and Delta Scutis. So
yep.
Very interesting. We published a paper with some colleagues about high amplitude Gamma Dorados too last month. We found more than 10, actually 20 examples of Gamma Dorados with several peaks interacting and causing an amplitudes up to 0.4 magnitudes. So very large amplitudes. So amplitudes are not restricted only to a couple of hundreds of magnitudes. There are some that have very large amplitudes because of that interactions. So it's a very interesting group of stars.
Those might be good to get on the page for people to follow up, like on the home SPP homepage. Give them, I think, new targets, something that people haven't done before, might excite a few people. So if you got those, we should probably get them.
Great. And actually, you know that the CTF group released their catalog a couple of months ago too. And there are a lot of things that were classified as spotted stars that are actually Gamma Dorados or other types. So they are hidden there and they need to be studied or reclassified. So that's another gold mine there to look.
So that is one of my questions too. How do you tell from light curve or spectroscopy or whatever if you've got a Gamma Dor versus a spotted star? Because I see all of these and I just say, well, they're a candidate Gamma Dor star, but they could be a spotted star. And then what is the frequency of Gamma Dors? Is it very small compared to the spotted stars? So is it really unlikely it's a Gamma Dor, or is it more likely it's a Gamma Dor? Can you answer any of those questions?
In the CTF database, we found those because of their colors. They were too blue to be spotted stars. So that's what the main thing that we found. Maybe colors were B minus B 0.2 and this is too blue. So, and the light curves were also different. Usually the spotted stars tend to have longer periods. So the 2 periods interact and you see mean magnitude changes. And that doesn't happen with the Gamma Dorados. That's all about light curves. That's the only thing I'm talking about. But you can see that those things, when you see long-term changes, this is probably spotted star and not a Gamma Dorados.
Right, so then that argues really that we really need the amateur observing to look at the long term, right? Because if you just have 3 months of Kepler data or 1 month of test data, you can't really, that's not necessarily long enough to tell if it's a Gamma Dor or a spotted star. Right?
Yes, exactly. When we get submissions to VSX of those stars only based on test data, we don't see the long-term variations and we are not able to classify them properly. But when they combine test data with ASASIN or other surveys, you can see those changes and you see, it wasn't a pulsator, it was a spotted star, but you wouldn't be able to tell only from tests. Yes.
And then the color photometry is really nice. If you can get the blue, if you can tell if they're too blue or whatever, because again, TESS and Kepler don't, it's one band pass and I don't know anything about the colors then. Yeah. Plus, I'm going back to Delta Scuti stars, and they're telling me that there are spots on Delta Scuti or on A-type stars. And if you do see them on bluer stars, then that isn't necessarily a criterion to rule them out on Gamma Dor stars.
And you usually have spectral types published only for the bright stars, not for fainter objects. So it's difficult to tell when the stars go fainter.
The fainter ones, okay.
Yes.
Right.
Yeah, and then you got to be a little careful that with some of the Delta Scuti periods that you start getting some beta Cephei's in there when you get the much bluer targets. And so sometimes it's a nightmare sometimes sorting these little guys out. So
I suppose SPB versus the Gamma Dor, because it's the same periods. Yeah.
Yep.
But no, you're right. I never know from a Kepler light curve if I've got a beta Cephei or a delta Scuti.
Yeah. I mean, that's where color really helps. And I mean, obviously there's spectroscopy. If you can get the radial velocity curve, that kind of solves just about everything. But as they get fainter, that gets harder. So that's Horace, that's what I might do with the 3.5 meters, some of that spectroscopy follow-up.
Sounds good.
Well, that brings up a whole other area then, the radial velocities. But are the Gamma Dor radial velocities too small to really tell that it's pulsation? Not for those high amplitude ones, I guess, but for the typical one. I thought they do find them in spectroscopy, but it's not easy, I don't think.
Any of the low amplitudes is always challenging because the variations, it's kind of like some of the, finding planets with radial velocity. You really have to have the high precision cross correlation process. So it's a little more challenging, but it can be done.
Another question I had is I met a student in, it's Emily Brunsden's student in England, and he is working on trying to make a database of, I guess he's a master's student or something, a catalog of Kepler test discoveries of Gamma Dor and delta, maybe more so delta Scuti stars. So he was asking me for places to start with to get that information. But has anybody done that, or where is the go-to place for a catalog of all the known delta Scuti or Gamma Dor stars, and how would you add to it if you were going to do so?
Oh boy, now you're going back to Eloy, right? Yeah.
Project, because I don't know the answer. Yeah.
You go far enough back, you have the classic Eloy Rodriguez catalog from years and years ago. Then there was a group, and I can't remember it. I was the referee on the paper. They were trying to redo the Delta Scuti catalog, but that's still probably about 10 years ago. That would be the one to start from. It was published. I want to say it's some reason I'm remembering like a TAOS, a TAOS or some. There's some acronym they had, and they had real problems in that catalog because they doubled names. So they'd catalog the same star twice because it had two different names in publishing. That's the last catalog I remember seeing of Delta Scutis. Gamma Dors, I don't remember.
But remember that you can always do a VSX search, and you have all types. You can do search by type, but any parameter you want. So I think it's the most complete list of stars will be searching through VSX, you will be able to find them. So
right. Yeah, I was going to send them to VSX. I only recently discovered how good that is. That's really complete.
Yeah, because now we have merged all larger lists of variables available anywhere. So we have millions of stars. So it's possible the best way to look for specific types.
They're completely verified or anything, but they're at least, that's a good place to start.
Yes, of course, we can say for sure that 100% of the stars will be properly classified. Actually, we know they aren't. That's why submissions, revisions are always welcome, because it's a live database, it always can be corrected. Survey types are usually automatically determined, so they might not be okay. So they need to be revised, but we can't make it one by one. Every time we import a list with 1 million stars, we can go check in individually. So we just dump them there. We see the major mistakes like those ones that I was mentioning about the spotted and Gamma Dorados, but those are just overall corrections, and individual cases slip through some mistakes.
Does VSX look at the literature as it comes out, and someone publishes a list of, I don't know, like,
yes, but
a list of 249 Delta Scuti stars from K2 or something?
Yeah, I remember I imported a list of bright delta Scudiers a couple of months ago. So we try, but we are not completely up to date. You know,
Right.
it's possible. We don't have enough manpower to do that. But we try to import most of the biggest lists that are published. But help is always welcome because we know we are behind regarding some of those lists. For instance, today there was a talk about the Kepler eclipse and binaries. Well, we haven't imported them yet. So we know we have some things to do, but it's endless. The number of lists is endless.
No.
But even then, we are the most up-to-date catalog. So yeah.
Okay. I know I have some lists of papers I published that weren't in, that aren't in the, the Simbad databases and things. They're just not, the list wasn't in a form that they picked it up because it wasn't coming from a major journal or something. So maybe I should send them.
Well, this is important we give higher priority to those lists that are BSX friendly, to say this way. When there are tables published with the relevant data, it's much easier to include them to BSX. We have cases that the information is so poorly formatted and presented that it's almost impossible for us because it will take too much time and we have other priorities. So we have published the CTF list because it was completely easy to import. But we have, for instance, the Atlas catalog. And this is very, very difficult. It's a nightmare. And I've been waiting there for 2 years now. And they discovered a lot of variables before CTF, but we couldn't import it because there has too many flaws. So it will be imported eventually, but we are doing the easiest first. Mm-hmm. The higher quality takes precedence.
Right, no, that makes a lot of sense, yeah. It's
yeah,
just
the Atlas.
Overwhelming. There's so many stars being observed. It's hard to keep up with it, I think. But it sounds like you're doing a good job.
Thanks.
Yeah, the Atlas catalog is a bit of a challenge.
Yeah, you have a lot of double periods, half periods. There is a frequency there. That's all. You don't know what the actual period is.
Yeah, I found most.
They don't present types of also standard types, just sinusoidal, things like that,
Yeah, pulse, impulse, and sine. I was doing this. Actually, that's the assignment for my students today, is going through Atlas. And I found most of the impulses are multiples. And as they get to lower amplitudes, they tend to miss the period altogether. So I've had some that it's not even a multiple, it's some bizarre different period on it. So I'll see what my students come up with today, whether anything's realistic or not. So I can see why you're having trouble with that one. Okay.
Any other spectroscopy people in here? I have a Lisa with about R1000 resolution, and I'm just getting started out with the symbiotic stars like Z and. So I don't know much about the short period pulsars yet. How do I find out what you need for like R1000 spectroscopy?
I can probably think of some things at that level. I do some fairly low dispersion stuff with a 1.8 meter in Canada, and that's actually really valuable. There's some things you can do with some spectrophotometry, convolving filter functions over the spectra, and those can actually come out pretty good. Mm-hmm. So that's one of the things on my list. It's actually on my board: Southern Hemisphere targets, spectroscopy targets. So I've got a whole list of things I need to get done that haven't gotten done.
Okay.
But I'd love to get you a list to play with.
Yes.
So hopefully that'll come sooner rather than later.
Okay.
Okay. And any other discussions here? We're open to all kinds of crazy questions.
And what's your name? Are you Eric? Or?
Yeah, I'm Eric.
Okay, great.
Yep. Yeah, I just logged it in, so I wound up having the funny name on it. So, yep. So, yeah, I thought about doing this from up in our observatory, so to show off the 24-inch upstairs, but I found out it was way too cold up there this morning. So I thought I'd stay down in my office.
Did you have trouble with the smoke from the fires in the West with observing?
There was a time when the California fires we thought were a heck of a lot closer because the night sky, Venus was, marginal, marginally visible, but it's gotten a lot better. We had a couple fires just locally that did us in for a few nights. So yeah, this was not a good year for smoke.
Actually, we've had smoke as far east as Wisconsin.
Yeah.
In Michigan, we could see it some nights.
And in Rochester, New York.
Wow. Well, I'm glad it's mostly cleared now.
Eric, where are you located? Are you in California?
Nope, we're in Provo, Utah. And so we, had to come across Nevada. So it was still pretty bad by the time it got here. So there were nights we could actually smell the smoke still, even though it was coming from the California fires. And when that happens, I just tell my students, don't pull the telescopes out those nights. If you can smell it, then it's probably not a good idea. So. Feet above sea level.
I lost about a week of observing. We had perfectly clear skies, but I figured if I can't see Saturn naked eye, it's probably not good enough.
Everyone has become very quiet. Well, speaking of the data archives, the new data archives, in some of the work we've been doing, we've been recalled, however, to the old plate archives. And they're thanking the people who created them long ago and kept the plates in a form where they could still be analyzed today, 100 years later, without worrying about what format the data were in. You might worry about what the sensitivity of the plates were and what color sensitivity they had, but at least the plates are still there to be looked at. And so the old plate archives are still of value for a number of the things that I work on anyway.
This is Richard Dabo. I don't know if my mic is messed up or not, but when we were at CCD school in 2012, we went over to the college observatory and saw their plate collection. And at that time, they were digitizing all of the plates, and they are apparently available on Dash online. Are you familiar with using that plate collection to go back and see if it has any short period pulsator data on it?
I have looked at it for a few stars. It's a very heterogeneous collection. So, of course, many of the plates are of different resolution and different color sensitivity. So that the Dash people have had trouble trying to put everything on a constant system. But they are, if your targets are pretty bright, you can still get some data that may or may not be useful depending on what other sources of data are available at the time. I've looked at XC Cygni, for example, which is an Auralari star, about 8th, 9th magnitude. And it's a Blasco star, meaning it has a long secondary period as well as the main period. And I found the Harvard data was good for the main period. You could see it, but it was hard to pick out the details of the Blasco period.
Well, one issue with a lot of the old RH plates is that a lot of times they were taking 2-hour exposures. So if you're looking for a star with a short period, it tend to get washed out.
Yeah, that's a good point. You know, and if you're looking at something with a near neighbor, you have a lot of trouble with many of the plates for very low resolution. So you have a lot of blending with near neighbors if it's a crowded field. But it's there, at least it's something you can look at. I remember having to go out to Harvard years and years ago when I was looking at a star and sitting there and going through eyeballing the magnitudes one by one on the plates. The people there were very, very helpful in getting out for me, but I always was afraid I'd drop them. But at least digitally, you won't be the one who's doing the dropping. I've had some people complain, however, that some of the old markings had to be erased from the old plates in getting the new scans. And some people were afraid that some historical information might have been erased with that removing of the old markings on the plates.
Well, at that process that we watched, they took 35mm pictures of both the notes on the envelope and the pre-washed plate. And then they washed the plate and digitized it. But all of those markings should be available because they did do a 35mm exposure of the unwashed plate.
Yeah, I think that was partly in response to these complaints people had, but I still hear people say, well, I wish we had the originals, but it's a tough thing to get everything. I guess the most important point about the early Harvard plates is that the past is gone. And if you're going to get anything from the past, it turns out that there's something you think happened to your star a long time ago. Really, you're left with things like the Harvard plate series, maybe some other plate series from other observatories. And they may be far from ideal from what you want to have, but they're in existence. And barring a time machine, what else are you going to do?
Yeah, we detected some large amplitude dwarf novae outburst in DASH data. So it's useful for large amplitude stars. Is very useful. For short period pulsators, well, it's more difficult.
Have you been able, on those cataclysmic variables, have you been able to get enough maxima to determine the periodicities in the old data?
In the examples I mentioned, no, it wasn't possible. No, not enough data.
I believe that. I rather expected that would be the case.
Yes, in mid-time series, it's difficult, and the accuracy is not enough.
But we do owe some thanks to those people out at night going from patrol camera to patrol camera back 100 years ago. Out in the, originally when Cambridge was dark enough to do the patrol plates from there. And then from outside of town, it's hard to think of doing your patrol plates from the vicinity of Cambridge nowadays.
Well, I know the Damon cameras were set up at Agassiz Station, which is west of the Boston area. And those were still in operation. Oh God, we visited that observatory, I don't know, 40 years ago or so.
I think, weren't the Lillers responsible for keeping that program going for a while?
I think so. Actually, the Damon plates, they had 3 cameras lined up and they were shooting 3 different colors.
Ah, excellent.
Eric, you have been muted for a while, for several minutes. We don't listen to you. Nope. Something is wrong with your equipment, your audio settings, because you're not muted, but we can listen.
That's
what you're
interesting.
saying. Now it's fine. Yeah,
Okay.
yeah. You're back.
I might have pulled a cable, but well, that's fine. You guys were having fun with glass plates. That's always fun. I remember those. That was a class project when I was at Case, because we had the Case collection of glass plates from the Burrell Schmidt, which was just outside of Cleveland for a long time. So those, I remember those plates. And I remember Billy Beitelman coming in quite often, running in with a glass plate, handing it to you and saying, "Look at this." And there's like probably 1,000 spectra on a glass plate. And you're like, which one? So it's been a while since and then I've got a box upstairs of Harold McNamara's glass spectral plates that I at some point probably need to get scanned. So that would be fun.
It's good that his legacy of work in the field is being continued there.
Yeah, we have one of the old students that's actually up in Salt Lake that still works on the RLRs that Harold was working on towards the end. So that's always fun. We've been kind of thinking when the AAS meeting is going to be out at in Salt Lake here, if we should try to do something for like Harold and then Hollis Johnson, because the connection to Salt Lake area. So
when is that going to be?
The AAS next not this January, next January. So 2022. So we'll be in Salt Lake that time.
Okay.
So, and that'll be cool. Hopefully they leave the Christmas lights up that year into when the meeting comes, because Temple Square up there is right near where the convention center is. So it's really gorgeous when all the lights are on. I don't mind the lights in Salt Lake. That's all bright anyhow. So. Okay. Anything else we want to discuss? We still have a few minutes here.
Does that mean all the questions have been answered?
I think we've solved the universe. We're done. We can go jump in some other groups and see if we can solve all their problems.
I think I'm going to go and take a look in one of the other groups if it's still going on then.
Okay, we'll see you, Horace.
Okay.
All right.
And talking about, well, everybody's going now, but I remember that if you want to do a VSX search of pulsating variables, you can also we have a search option that includes just groups of variables. So you can get a list of all pulsating variables, no matter what type they are. So you can split by types, by group, by everything you like. So you have to keep in mind in case you don't know that, you can do that. So.
Okay. That's good. Hello, Gordon.
Hello, how you doing? I'm jumping around looking at everybody. How's it going?
It's going well. We've solved the entire short period pulsator problems. So
wonderful. No remaining questions, huh?
No, I think we solved everything. Don't tell the observers that. We still want them to take data, but
yes, once in a while.
It's interesting that there are still new types of pulsating variables being discovered. You know about the BLAPs, the blue large amplitude variables that the Ogle team discovered some years ago. They're very interesting. They only have periods of minutes, but their light curves are like RR Lyras. So, but they are faint. That's the problem. But they're very interesting. I haven't seen many work on those yet.
Yeah, and I think
that's the problem, because when you have periods in the minutes and you think about how faint they are, and you have exposure times that are in the minutes, it's really hard to get the kind of resolution you need.
Yeah, it's difficult. Yeah.
Yeah, I think the Atlas team was talking about a new subclass of pulsators too. At least a couple AAS meetings back, you were talking about another one. So there's a lot of them.
You mean those with light curves showing two bumps? Some strange things like that, but I'm not sure if they are eclipsers or pulsators, actually. I don't know if you're talking about those.
No, I think it's a different one. I was chairing the session, and they were talking about, it was a pulsator, but it had a little bit longer period than you'd expect. And so it was a kind of a funny one. And actually, I think it was, they were multi-periodic, and kind of the period ratio was a little goofy on them. So I don't know if they followed up on that one or not, but I need to get in I was playing around in that archive yesterday, so I need to get back in there. But you're right, with their designation of pulse, M-pulse, and sine, it doesn't do a whole lot of good.
Yeah.
So hopefully I can fix a lot of those and then send them to you to get the right type in. So that's what we're doing a little bit of.
Yeah, if we can reconcile them with some known type, it will be interesting. But they don't have many observations to determine good types sometimes. I don't know what's the average number of observations. Do you know how many?
Usually it's what I've seen most of them is maybe usually less than 100 in a lot of cases, and they're spread out. One star we got, I don't know how many data points, but a beautiful clean curve. And the most data they had in a single night was like 6 data points. So for short period pulsators, you can get all kinds of effects that get washed out. So
yes, that's why they got that type stochastic, which might be anything. Yes.
Yep.
Well, but you also have the Pan stars RR Lyras, that catalog that has a lot of stars, but most of them are not actually RR Lyras. You have a lot of CVs hiding there. So you have everything inside that class. But they published a probability, a number saying how probably was that the star was or not an RR Lyras. So we only included, for instance, stars more than 80% likely to be RR Lyras, and all others were not included to be SX, and they are turning out to be CVs, eclipse in binaries, whatever. So sometimes you have this. Those survey results are very low quality. So, well, actually, Atlas has millions of stars classified as dubious, and we are not taking those into account because they might not even be real. So
right. Yeah, I'm kind of hoping that we can feed some information back to them of what works and what doesn't of their classifications, and maybe they can do a reclassification and maybe get something that is useful to you.
sometimes they rush to publish and they want to get them out and that's it. And you don't pay attention to other things. Maybe it could have been done better. I don't know, but anyway.
Yeah. Yep.
The Assassin team made a good work with their catalog. The classifications are rather good. And they sent us their list of variables to us. So we were working on the format and everything before the papers were published. So they were very collaborative with us. So that was nice.
Yep.
If I could throw out a totally different kind of question than asking in some of the other breakouts, how are the observing sessions? How do you find the forums? Is that a decent way to communicate? Not? Do you have suggestions for how we could make the communication in the forums more effective?
Comments?
Anybody? How do you, I mean, some people look at the forums as very old-fashioned communication mechanism in this new world, but nobody seems to have or at least we don't have a consistent opinion of what might make things run more effectively. And I just don't know what you all feel.
My opinion doesn't count because I'm all day connected. I'm looking through forums to email to everything. So I will shut up.
Well, I just recently subscribed to some forums, including the data mining one. I just got an email from Colin Littlefield and signed in for that now. So I get these emails that, you know, just randomly as people are posting in the forum, and they go into my general email box, and it makes it hard to find them later. I know everything's back and collected on the forum, but I don't know if that's how effective it is. I'd like to see something better. Do all of you work a different way? Do you go to the AVSO webpage and read the forums every day, or make it a habit? How do you do it?
Personally, I am subscribed to all forums, and I get a notification every time a post is written. So I look at the ones I want to look at. I get all.
Yeah. You
can subscribe to all. I know it's too many, maybe.
Yeah, I know that's because that's the problem I have. I get so many emails. I be blunt. I don't read them all, right? That I miss something I didn't want to miss. But
actually, a lot of things what'll catch my eye is when I'm on the AVSO site. If I see a topic that looks interesting on the homepage, I'll go ahead and read it. And I wonder if it wouldn't be better if we listed more of the recent forums than just 2.
Okay, that's good observation.
Now, even if we made that box where you have a scroll bar, you could maybe look at the last dozen or so.
Yeah.
Sometimes the topic title is not very descriptive, so that makes things worse. We should try to describe what we are talking about in a better way, so everybody knows what the post is all about.
Well, that's the email problem in general, that people will, something starts on topic, then the topic drifts and they never change the title.
Right.
Yeah.
Well, let me ask you a slightly different question. The target tool, do you like it? Do you not like it? Do you use it? Is it a way to communicate? Is it actually used to communicate best targets, for your section?
I'll be real honest, as an observer, I never use it.
Yeah, I mean, I've looked at it. Actually, I have it open on the screen over here. So I was just sort of curious as to what it said. And, and to actually answer your other question, I mean, I think the forums work to the extent that people use them. I think the bigger issue is they're pretty silent. And so are the section pages and things. There's just not a lot there. And especially for somebody like me that, I mean, I do a lot of observing, but not, I'm interested in this. I got interested because of Eric's presentation at one of the earlier webinars. It was quite good. But yeah, you go look at the short period pulsators, and there's a ton of them here. And, you can kind of tell who's observing, that some are being observed, but beyond that, there's just really no guidance as to, you know, what's useful, right? As opposed to just, here's a bunch that you could observe, right? I mean, and to some extent, everything's useful, but, you know, there's only so much telescope time. So, you know, what do you do? You know, right. And I think more importantly, I mean, my personal take is that I'd much rather collaborate with somebody so that I know that somebody is going to use it, because I'm an observer, I'm not a scientist, and you know, I'm interested in all of that, but you know, if there was some way to get a little bit of guidance saying, hey, can you go do this, or can you go do that, and you know, that would be helpful. Instead of just shotgunning it based on. Go ahead.
Yeah, something I've tooled around with that hasn't ever seen the light of day, but I would like it to, is sort of breaking up projects like you see with the alert notices and things, but having more things that are longer term, things that would last for, you know, maybe a year or more, and then be separated by observing type. So you could go to the short period pulsators page and it would say, like, here are some active projects that you can contribute to now. Here are the people involved and here's what they have to say about them. If people would appreciate something like that, then it's a place where I would put more effort in the future.
Yeah, some of the target or lack of targets on the SPP page is my fault. I've been wanting to get more things exactly what you're saying, lists of targets, exact, you know, I need help with X, Y, and Z, and it just hasn't happened yet. So
is part of that due to it's difficult to change your own, you know, the section web page? I mean, is this partly a IT issue, or is it this time?
It's time. When I send stuff in for IT to put, or into the AVSO to get a page modified, that happens instantly almost, you know, and relatively speaking. It's just complete, too many things going right now. The pandemic is, you know, doubled the number of things I have to worry about. So, but I am trying to get that up. I'd like to get some, like the request on Southern Hemisphere, some specific projects in the North. Some of the things like Horace and I were bantering a little bit back and forth about things we've worked on in the past, trying to get some of those kind of projects with some newer targets would be really kind of fun. So hopefully everything will settle down and I could get a whole beautiful list on there, and we'll see.
Well, yeah, and back to the tool question, I'll just be, you know, painfully blunt, as I tend to be. When I go to the tool, I just am swamped with so many targets it becomes useless. I mean, it's the reverse of the situation. You know, I do a lot of CVs. I go there and there's, I don't know, 100 that are saying they all need observations. And the question is that a tool issue? And what I mean by that is there's some capability that you all from your section would like to say, here are the top 5 or 10, that there's, you know, there's no easy way to do that. Or is it, you know, that really having a separate list on the section webpage would be easier to handle? Well, you don't have to answer. Just think through it. Think through. We're really trying to work, as Bert well knows, we're really pushing to make the sections even more effective. And our belief, which has been confirmed from a lot of the work we've done the last couple of years, is that that's how members get engaged. That's when they get interested, when they're sure that what they're doing is meaningful and they're getting feedback and they can participate in a group, kind of a camaraderie kind of thing. These are other people interested in what I'm interested in. And so we're trying to figure out what we need to do in terms of tools and communication to make that easier. Yeah, I see Josh's notes. This feedback is most important. I absolutely agree with that. It's why everybody always mentions Joe Patterson, because he's got his CBA group, and even though he's not very consistent, he does give you feedback. And when there's something critical going on, you know about it.
Yep. I kind of like the idea on the page itself, giving more explanation, because I think that is one thing I've heard before, is wanting to know why it's important. And then the target page is good to then get the information, point people to that. But I don't know about going to the target page looking for a target. I kind of like the idea of giving the information, because a lot of people want to know, I think, what their observations are going to feed into, and that might be better on the pages.
Yeah. Okay, I appreciate it. I'm going to dive out and go take a look at one of the other, just kind of going back and forth among the sessions. Thank you very much.
See you, Gordon.
Yep.
Bye, Gordon.
Bye.
Well, we're down to 6. I think we've covered everything that I can think of.
Now,
I wanted to ask if anybody has used the Slack interface much, and what you think of it. I keep getting invited to these Slack channels to collaborate with people.
We use it extensively at HQ. All our communications are through Slack. Yes, we have a lot of channels. Yeah. It's useful.
Yep. We use it extensively. Actually, I'm right in the middle of a proposal that's due on Monday, and there's it's just collaboration, and we've got a Slack channel here that I'm keeping my eye on to make sure, in case something needs to be modified at the last minute. So, and I use it with people I work with that are at different sites. It works pretty well. It's lighter than email, but I don't know if it's appropriate for something like this, because it's meant for fairly real time things. But anyway.
So do you just have it open, have this window open, and you watch the comments come through like in real time?
Yeah. It's just it's like a chat, and then it's, I have it on my phone too. And so if something happens, my phone will ding, and I can go, look at it through the app on my phone if I'm not in front of my computer. So, yeah.
Actually, right now we are using it in case something goes wrong here. We are constantly communicating through Slack to see, hey, I couldn't open the meeting, I couldn't start it, can you do it for me? Things like that. So right now it's very useful for us. Yes.
I have to admit, I first signed up for it 2 days ago, and I really haven't used it at all.
I realized because you weren't there today, and I was asking, could you start a meeting? And no one was there. Could you start it? And I just joined, and you were there.
Well, maybe I'm a little more old-fashioned. I'm used to using Skype. Back when I was working, that's how the company always communicated overseas. But I've been retired now for 4 years, so I don't know what's current.
I still use it. I have to mentor someone today, no, yes, tomorrow. So I still use it too, yeah.
Okay.
Well, guys, I think we can finish it.
I think so. It's good to talk to everybody.
It was great, yeah.
Thank you. Thanks for answering so many questions I had. It was very useful.
Good. Okay.
Right, if you need any help with a VSX search or a list of candidates, just let me know, and I can help you with that. Okay. Well, see you at the membership meeting tomorrow then. 16 UT. Yes.
Yep. Okay. Bye-bye.
Bye-bye.
Well, I got blue sky right now, so I might have a good night tonight.
The storm's coming here, so.
All right. I'll see you tomorrow.
Yep.
Bye.
Bye.